Hello everyone and welcome back to the channel. Today we are going to solve one of the most popular interview question, LeetCode 146 LRU Cache. This question is heavily asked by companies like Amazon, Google and Microsoft. Before we jump into the code, let's quickly understand what a cache is. In computer science, a cache is a temporary high-speed data storage layer. It stores data so the future request for that data can be served much faster. There are different types of cache based on eviction policies like FIFO. First in, first out, LFU, least frequently used, and what we are building today, that is LRU, which stands for least recently used. So, what exactly is an LRU cache? Imagine a cache has a fixed size, let's say capacity of 2. We keep adding atoms to it, but what happens when the cache is full and we want to add new atom? We have to remove something to make space. An LRU cache drops the least recently used atom. This means the atom that hasn't been accessed or looked at for the longest time get kicks out. Whenever we read an atom using get or update an atom using put, that atoms became the most recently used. So it moves to the front of our list. To solve this problem, LeetCode requires both our get and put operation to run in order one constant time. To achieve this, we need two things: a hash map to look up values instantly by their key in order one time, a way to maintain the order of usage. Usually, people build this using custom doubly linked list, but today I am going to show you a very clean, elegant solution in Java using linked hash set alongside our hash map. The hash map will store our key value pairs. The link hash set will keep track of access order since linked hash set maintains insertion order and allows order 1 removal and addition. It is a perfect for tracking which element is the oldest. Let's start coding this solution. First, we define our class variable. We need integer for capacity, a set of integer called order set, order set which will be initialized as a linked hash set in the constructor and map called cache. Let's initialize this in constructor. The capacity like this dot capacity is equal to capacity, this dot order set, new linked hash set, this dot cache is equal to new hash map. Now let's look at the get method. If the key does not exist, we need to return -1. Okay, that's what it mentioned in our explanation. This one, right? This one. So let's incorporate that it value is equal to -1 if cache contains key. Okay, if it does not contains, we will return this value. If it is contains, then we need to refresh the position of this key. Okay, whatever the current position, remove the key from that position from order set and add it, write it back, which is the end of the list. Okay, let's do that. So order set dot remove dot key, then order set dot add key, and then finally update the value as cache dot get key, and then at the end return the value. Okay, next is the put method where the we need to insert the key value. Here first step is check whether key already exists or not. Okay, if cache dot contains key, then update that cache dot put key value and call our gate. Reuse the gate method to handle the update, its usage and or return. Okay, so handle like we need to refresh the position of this key because it was accessed recently. So let's reuse the gate, which we are doing the same thing in gate, and return. Okay, the case 2, right? If it is completely new key and we first need to check whether cache is full, we will compare the capacity with the cache size like this. If capacity is equal to cache dot size, if it is full, then we need to remove the stale key or stale key from the order set, right, to make the space for the new key value pair. So let's get the stale key, int stale key using order set. Key is equal to order set iterator dot next. Remove from key cache dot remove stale key. Finally, like whether we had to evict an atom or not, we now have a space. We put the key value pair into our cache and add it to the order set. Cache dot put key value order set and to really understand how this works, let's do a quick dry run with a small example. Let's assume our cache size has a capacity of 2. We will perform 4 operations: put 1 comma 10, put 2 comma 20, get 1, put 3 comma 30. Let's see what happens step by step. In step 1, put 1 comma 10. We go to the cache and the cache is empty, so we just go and add the key value. So key is 1, value is 10, and also with that we need to add into the order set. So we will add key in the order. Okay, in step 2, put 2 comma 20. We go and check the size of the map, which is 1, and the capacity is 2. In size is less than the capacity, we just go and add to the cache or map, where key is 2 and the value is 20. Along with that, we need to add into the order set as a 2. Okay, so here from this order, like the oldest atom is 1 currently. In step 3, get get 1. Okay, when we go to the cache, we found the key. Okay, so this we recently accessed this key, right, this key. Okay, so we need to remove, like change or refresh its position in the order set. So in order set, we just need to get we just need to remove this from whatever the position the one is, and add it to the end of the list. So our order set will be like this: v1, this is v2, this is 2 and 1. We are just adding to the end of the list. Okay, in step 4, where the magic is happen, like when we are putting the 3 comma 30, when we go to the map and found that like the capacity of the capacity and the cache size is equals, that means we need to make the space for this new key. For that, we need to remove the oldest atom. Okay, here if we are using the link hash set, and if we get the first element from the link hash set, that will be the oldest one. So that's why we will remove this 2. So we will remove the we will get the stale key as a 2. Okay, go to the order set and remove that from the order set, so order set will be like this. Okay, and also from the cache we need to get rid of this, so we will remove the 2 also. And then once that is done, we need to like add 3 into the cache as a key as a 3 and value as 30. Along with that, we need to update the order set as 1 comma 3. That's it. Let's run this code. Let's submit it. As you can see, it passes perfectly. By utilizing Java built-in LinkedHashSet and HashMap, we achieve order 1 time complexity for both operations while keeping your code incredibly clean and easy to read. If you found this video helpful, please give it a thumbs up, subscribe to the channel for more LeetCode explanation, and leave a comment below if you have any questions. Thank you for watching, and I will see you in the next video.